I introduced limits on the first day of STEM calculus. This video begins after groups of students report their thoughts on topics such as, why does a negative times a negative equal a positive? I do this to foster teamwork and set an expectation of discovery and deep thinking. Wow, that was great. We had our group just talk about why a negative times a negative is a positive. That's the hardest topic that I gave out today. So I'm hoping you're getting the idea that being in this calculus class is not something that you're going to sit back and just relax, that you actually have to spend a lot of effort thinking. It's good exercise for your brain to be in here. And we have one last topic, and that is, why can't we ever divide by zero? So let's take this group. If you could come up and introduce yourselves and come up to the front and explain what you came up with.
Yeah, so I'm Tim Knight.
I'm Wyatt Davenport.
I'm Francisca Nunez. Dalia Espinosa.
Okay.
So what we've come up with is you're unable to divide by zero because it's undefined. So if you divide by, let's say 1, you're dividing the number by one integer of itself instead of 0. If you divide by 0, you can't divide that number by nothing of itself, so that makes it undefined.
Ah, okay. If I had like a board, and if I'm dividing it into, it's 10 feet long, I'm dividing it into 6-inch pieces, then I have 20 pieces, right?
Mm-hmm.
So that's what that fraction means. But if you are trying to divide by 0, how does that work with this board? Because you've got a board, but now you have 0. You're cutting it into pieces of 0 width, and that just doesn't work. Is that what kind of what you're saying?
Yeah, it would be like infinitely small pieces that you divide the board into, so you can't define it as an actual number. Like this board is divided into X amount of pieces, 20, 30, 50. Since it's 0, it's an infinite amount of pieces going on.
Awesome job.
All right, I'm Elias Gardenas.
I'm Bree Ukowicz.
I'm Kendall Gwynn.
And the explanation we came up with was, if you had, I will use the board, if you had 7 cookies and you tried to divide it between 0 people, you could not share your cookies with a group of people. You would have 7 cookies that could not be shared. That's why you can't divide by 0.
That is awesome.
We just kept it simplistic.
That is simplistic. Okay, thanks. Thank you. Great job. We're going to start by looking at that, dividing things into pieces. And we're going to start by looking at y equals 1 over x. Because that's a thing that you would divide by 0 if you put 0 in here. First of all, let's talk about this. Can you get a y value of 0? Is there a number? Can you think of a number that will give you 0 out of that?
No.
No. No. So what's going on here? So if we look at dividing things, and we take our whatever it is, and we try to divide it, and we cut it into pieces. That's like taking 1. So if this is 1 foot long and we're dividing it into pieces, maybe cutting it into things that are 1/2 inch long or something like that. How many pieces do we get? 24. So let's put this both in inches. Okay, and if I keep going with that, what if we cut that 12-inch thing into pieces that were 1/4 inch long? How many would I have?
48.
And if we kept going and made these smaller and smaller and smaller and got that almost infinitesimal size, what's happening with the number of pieces we have?
It's increasing.
It's increasing very dramatically. Let's just do a quick review of how fractions work. So if you have a number on top and you're dividing by a fraction, that's the same thing as this. And a lot of people have trouble remembering this. I know some of you have not taken a math class for a while, so we're just doing a quick review. So if you have a plain number, you can always write it as that number divided by 1. And then you flip and multiply the bottom to get your answer. But look at that, we're dividing by 1/100th and we end up with a pretty large number. If we start graphing this, it looks like this. We start at 1. If we have something that's 1 long and we divide it by 1 piece, we get 1. So we're gonna have this situation. But then after that, as we go to 1/2, that's gonna come up to 2, and so on. And we're going to zoom up like this, but are we ever gonna hit 0? No, we already figured out we're not. So that's kind of funky, isn't it? It's kind of a graphical way of saying, no, we really can't divide by 0. So we need some kind of notation for this mathematically. So let's look at our notation. We're going to say the limit as x approaches 0. And we're coming in from the right side, so I'm going to put plus here, of 1/x equals, and what's this heading toward? What's our y heading toward? Infinity. So let's dissect this a little bit. So this part means x is approaching 0 from the right. And this is our word we use for when things are approaching things, is limit. And you can see in this case it looks like a limit, right? Because our graph is kind of limited by that axis there. This is going to be whatever our function is, and sometimes we just put f of x here instead of the 1/x, or you can put a y here. That's not typically done, but this, whatever this is what we're looking at. This is the y, and that equals infinity. Let's write this out in words. If x is approaching 0 from the right, what is y approaching? And the key word here is approaching. It may get there, it may not. In this case, it's not getting there because we're dividing by 0. But that's the key word when we're looking at limits. Let's look at the same thing coming in from the left.